Alright, so today we're going to be covering 7.6, which is going to be covering logarithmic rules. So before we get into any examples, let's just talk about the general rules that you're going to need to know. Now, you don't have to memorize these because you will have access to your notes on the test and quiz, but it is important you know where they are in the notes. So make sure you know where to look for these because they're going to come up quite often. The first important rule you need to know is that if you take the log of 1, it doesn't matter what your base is, the answer is always 0. Okay, so if you take the log of 1, it's always going to be 0. Doesn't matter what the base is. Next, if you take the log of the base, the answer is always 1. So if you take log, if you have log base 3 of 3, it's going to be 1. If you have log of base m and it's of m, it's going to be 1. So it's always going to be 1. Okay, next time just tell me, I'll pause the video. So basically, if these two numbers match right here, the answer is going to be 1 in your log, okay? And these are just tricks that allow you to save time. You guys all know that we've learned how to solve these problems other ways and use proper methods, but these are just ways that you can do it without doing all that extra work. So rule 3, move the exponent in front of the log with the power rule. This one's really, really essential. If you have log of something, of some number, and it's to an exponent, you're able to bring that exponent out front and multiply it by the outside of the log. Okay, that allows you to get rid of the exponent in the log, and that allows you to proceed with the solving of the problem. And then lastly, this is called the change of base. This will require you to use a calculator. So does everybody have a calculator if you don't have one of your own? Okay. So as you know, these are the calculators I have access to in my classroom because I also teach an EOC course. These are EOC acceptable calculators. But if you have your own calculator that is a little more advanced, like a graphing, or one of the more advanced scientific ones, you're welcome to use it. This is not a required calculator, it's just what I have. So if you are working with this, the steps are a little bit different than with the graphing one, okay? So I'll talk you through the steps on here if you need it. So yeah, let's go ahead and get started. Reminder that if there's no base on your log, the implied base is not 1, but 10. You remember 10? Okay. So I'll zoom in here and we'll get started. So we just learned earlier that you take log of 1. Does it matter what your base is? Because the answer is? Good. So if a 1 is present right here in your log, the answer will always be 0. And the reason for that is anything to the 0 power is? No. 1. 1. So what is the implied base on this log right here?
0.
No.
Oh, wait. Oh.
Does it matter what the base is here? No, because the answer is? 0. If this number is 1, that's all that matters. The answer is 0. And that's because anything to the 0 power is 1. Okay, next one. We have to use what we call the power rule. This is an exponent. We allow the exponent to come outside of the log. Okay. What is log of 1?
0.
What's 4 times 0?
0.
So the answer is 0. And then next, log base 3 of 3. What is that? 1. Same base as what you're taking the log of. The answer will always be 1. So do we have any questions before we move on to the next row? All right. So here we go with this one. First, I have an exponent. What do I have to do with that exponent?
You have to move it to the front.
Good. Multiply it out front. And then we have log base 5 of 5. What is log base 5 of 5?
1.
7 times 1 is?
7.
7. Very good. First step on this one, what do I have to do with that exponent?
You gotta move it to the front.
Good, I gotta bring it out front. Now I'm gonna write in the base here, which is an implied base of 10, right? Everybody see why I did that? Now, what is log base 10 of 10?
1.
So 3 times 1 is?
3.
3. Okay. Questions so far? Pretty easy, right? Okay, so this one's a little bit different. You have 2 different ways to go about this. Actually, you really have like 4, but we're only going to address a few of them. So, there's a way I can rewrite 16 so that it has a base of 2. Any ideas? 16 or 2 to the fourth power. Everybody see how I was able to replace 16 with 2 to the 4th power?
Yes.
Because 2 to the 4th power is 16. Now what does the log rule say I can do with this 4 right here?
You can move it to the front.
Good, I can bring it out front, which gives me 4 times
1.
Good, yeah, exactly. So as you can see here, I have log base 2 of 2, which we learned is,
1,
so 4 times 1 is
4.
4. Questions about that? Okay. So our goal is to get 81 so that it has a base that is the same as the base here. So 3 to what power would give me 81? The 4th. What can I do with that 4 now? It gives me 4 times log base 3 of 3. What is log base 3 of 3? 4 times 1 is 4. So far, make sense?
Yeah.
Okay. Cool. So yes, there are ways to rewrite this and we can change the base and all of that, but I want to show you how the calculator can do this work for you. Okay, so everybody watching carefully. Anytime you have log with a base of something, you can rewrite it as log of 27 over log of 81. So whatever the log is of over the log of the base. Okay, you see that? Where those numbers went? So here's the thing. The calculator assumes an assumed base of 10, okay? So this is doing log base 10 of 27, log base 10 of 81. It assumes the same base. That's what allows us to change the base and use this formula. So here's how you do it in your calculator. Are you ready? Everybody have one? Okay. So you're going to type in 27, and you're going to hit that log button on the top. And you should get 0.43, so on. Divided by 81, and then hit the log button, equals. What did you all get? Good, 0.75. What is 0.75 as a fraction? Anyone know?
3/4.
Good, 3/4. So just a reminder of what log means, the setup means. This means that if I want to get 81 to 27, 81 to the power of 3/4 is equal to 27. Okay, that's how you can convert it back to exponential form. That's what this means when we do this operation. We're trying to figure out what power can I put 81 to that will give me 27, and we just came up with that calculation. Okay, that's what this is actually doing effectively. It allows you to solve for a missing exponent. So here, if we read it that way, we're trying to figure out what I can put 5 to the power of to get me to 125. And you might know that one off the top of your head, but let's go ahead and do it in the calculator to practice. So that's log of 125 over log 5. Now if you have a fancier calculator, you type the log button first. But on these standard calculators, you hit the number first. Okay, so you ready? So you type in 125, you hit that log button on the top, divided by 5 log, equals. What did you get? 3. So that makes sense because 5, the base, to the 3rd power is equal to 125. We just found what exponent would get me there. Does that make sense to everyone what that means? Okay. Now this one's going to be a multi-step problem. So let's go through the steps together. I'm going to convert this into a fraction, a log fraction with change of base. This is going to be log what over what? Log of over. Good. Plus, now here's the thing with this one, I have that exponent. What is the exponent going to do? Go to the front. And then once it does, now I can do the rest of this to a fraction, right? That's going to be log of 27 over log of 3, right? So this is all calculator work at this point. What you're going to do is, you're going to calculate this in the calculator. So you're going to do 27 log divided by 9 log equals, and you should get 1.5 plus 2 times whatever this comes out to be in the parentheses. So once again, we're going to do that operation in the calculator. So 27 log divided by 3 log equals, and you should get 3. Okay? Everybody with me on that? So, do we do addition or multiplication first?
Multiplication.
Good, because PEMDAS, order of operations, those never change or leave you in math, okay? They're always going to be there. No matter what level of math you're doing, they still come into play, okay? Any questions about number 11? Anything you'd like to address? Any confusion? Any calculator issues? No? Okay. Anybody want to help me set up number 12?
Sure, I will.
Okay, go ahead.
Okay, so you're gonna do 32
Good. Log of 32 over
4.
log of 4.
Then you're going to take the log of 2
Mm-hmm.
over 4.
Good.
And then you're going to do log of 32.
Good.
And then you're going to divide by log of 4.
Good.
You're going to get the answer.
Good.
And then you're going to do log of 2
Mm-hmm.
divided by log of 4.
Good.
Then you're going to subtract it.
Good job. So when you do each of these calculations individually, you should get 2.5 minus 0.5, which comes out to be 2. Any questions about that? It's pretty easy, right? What? Alright, well, you keep practicing, you'll get it. It's just a lot of calculator work. Okay, so you remember in 7.4 or 7.3, you remember where we had these equations where we had to change the base of this to match the other base? So we were rewriting like 3 to the, we were rewriting 9 as 3 to the second power, and then setting the exponents equal to each other? Y'all know what I'm talking about? Okay. So here we have a scenario where we have a base, 2 bases that cannot be converted into a common base. There's no way to rewrite 6, unfortunately, to a common base, okay? For 8 you could rewrite possibly as 2 to the third power, but 6 not so much. So this is where logs come into play. When there's no way to rewrite that particular base, you use what's called the log rule. So here's how you use it. First thing you always want to verify, is the number that is 2, the variable exponent, alone on its own on that side of the equation? Yes. Okay, if it's not, you need to get it by itself. So add a number over, divide a number, whatever operation we need to use. Once we've confirmed that, we're going to take the log of both sides. So log of 6 to the 3x power equals log of 8. Okay, you just take the log of both sides. Log is a tool, or a logarithm is a tool to find a missing exponent. Okay, we have a missing exponent, we're using the tool. Now, the power rule states that what can I do with this 3x? It can go out front. Everybody see what I did there? Okay. Now, for the sake of clarity purposes, I'm just going to rearrange this over here. This is really just 3 times x times log of 6. Log of 6 and log of 8 are just numbers. If you put them in the calculator, they're just decimal numbers. So I don't want you to treat them any differently. So I can rearrange this to be x times 3 times log of 6, right? Why am I able to rearrange those two terms right there? The 3 and the x, why am I able to flip those around? What's 2 times 3?
6.
What's 3 times 2?
6. It's basically the same thing.
Yeah, you can move things around. Anybody know what that property is called?
Distributive property?
Not distributive, commutative property. Means that we can rearrange in multiplication and addition, right? So everybody see why I was able to rearrange them? Yes, no, maybe? Okay. So our goal is to solve for x. What operation reverses multiplication in math?
Division.
Good, so we're going to divide both sides by 3 times log of 6. Okay, x equals. So this is all calculator work here. So I'm going to tell you how I personally put it in the calculator that I find the easiest, but there's a few different ways you can do it. So everybody ready with their calculators? You're going to type in 8 and hit the log button. Then you're going to do divide that by 3 equals, and then divide 6 log equals. What did you all get?
0.38 something.
Yeah, did everybody get about 0.38 something? So that's approximately, we use these squiggly parentheses when we round. I'm going to round to the hundredths place, 0.39. Now, just for clarity purposes, I want to explain to you how you could check your work on this. So, say you're on an SAT or something and you forget how to do this, but it's a multiple choice question. You could take each of the multiple choice answers and plug them back into the equation, right? So I could just take the original equation and replace the x with our approximation. And it should be true that 6 to whatever the 3 times 0.39 power is going to give me 8, approximately 8. It's going to come out to be like 7.99 because we rounded, right? So it's not going to be quite exact. But this is a way to kind of check your work, okay? So this is just to check your work. This is the answer. I just want to show you how you could check your work, okay? All right, so for number 14, first thing I want you to do, when you see you have an exponent with 2 terms, everybody see how I have 2 terms in my exponent?
Yes.
I want you to put those in parentheses before you do anything else, okay? Very, very important. Order of operations, you'll see why it becomes important. I'll talk a little bit about that. Now, we've determined that we have our variable to the exponential power alone on that side of the equal sign, so we're going to take the what of both sides? What did we do over here? We took the log. So we're going to take the log of both sides. I'm going to move away from this now. So we log this and log of that. Okay. What does the power rule tell us we can do with this exponent?
Put it in front.
Put it out front. Everybody see where I'm at right now? I just brought that exponent out front, right? Alright, so here's the reason that the parentheses were so important. If they weren't here, this would look like x plus 4 times log 3. But this is x plus 4, then times log of 3. Do you see the difference? Do you guys know what an Oxford comma is in English? No?
What that one?
You guys never heard of an Oxford comma?
No, I don't know either.
Okay, so an Oxford comma is like when you change, it changes the whole meaning of a sentence. You know,
Yeah.
if you put the comma, that's exactly how order of operations is in math. Okay, it's like an Oxford comma. It's this difference between saying x plus 4 then times log of 3 or x plus 4 times log of 3. 2 different things. Okay, so that was just my example to try and show you what that means. So my goal here is to solve for x. So I have product here. So to reverse multiplication, I do division. And then I'm left with x plus 4 is equal to log of, I'm just changing 1/2 to 0.5. Okay, you don't have to. It's just easier for me to work with. And we get that. But we're not done yet because we still have to do what to get x by itself? Good, subtract 4. So we get x is approximately equal to whatever all of this is in the calculator, okay? So, in your calculator, you're going to type in 0.5. You hit the log button. Divided by 3 log equals, and then subtract 4. So you're going to get a pretty messy decimal. Negative 4.63. Everybody get that? Okay. And you could always check your work by plugging it back in to verify that you get the same answer. Okay. Alright, last problem we're going to do today is number 15. I need to get this term by itself, so what's my first step going to be to do that? Add the 2 over to get the 3 to the power by itself. And notice that I immediately put my exponent in parentheses, okay? So when I was in college in my calc classes, My professors were always saying, you use a lot of extra parentheses. And I definitely do that. But for me, it's better safe than sorry. It's better to use too many than not enough. Because you can use a parenthesis extra and it's not going to affect the answer. But if you forget one, that's going to make your problem messed up. So I always put in more than necessary sometimes, but I find it helps. So now I'm at the stage where I can take the log of both sides, okay? So I take the log of both sides. What's going to happen with my exponent?
Front.
Out front. And then we just divide by the log to get it to the other side. So we're just doing like simple algebra here, but it just looks messy with all the logs. It just looks different than you're used to seeing it with all those logs in there. Now the parentheses are no longer necessary, so I'm going to remove them. So I just have 2x minus 1 is equal to log of 5 over log of 3. Log of 5 over log of 3 is a number. Okay, it's just a decimal number. But I leave it like that all the way to the end of the problem for sake of accuracy. If you plug that in and round too early, your answer is not going to be as accurate. So then I'm going to add 1 to both sides. And then I'm going to divide both sides by the 2. And x is going to be approximately whatever this is in the calculator.
1.23.
It is 1.23. Very good. Would anybody like me to talk you through how to put this in the calculator? Yeah? No? Okay, let's do it. So you're going to type in 5 and hit the log button. Divided by 3 log button equals plus 1, then divide by 2. And you should get 1.23 something. Do you all get it? Alright, we'll do it one more time. You ready? Type in the 5 and hit the log button. Divided by 3 log button equals plus 1 equals divided by 2 equals. Questions? Alright.